Hello guys, welcome to my channel. If you are here to learn finding moments on the beam, then you are on the right channel because in today's video, we will walk through another sample problems of determining moment in the beam with different load arrangement. So let's dive into the problem, and here it is. Find the moment at the center of the span of the beam as shown in the figure below. So we have this beam arrangement with different load configuration. So basically we have the triangular load, varying load of 140 pounds per foot, and we have also 1200 pounds low concentrated load at the third points, 5 feet on centers, as well as 2700 pounds concentrated load at the center of the span. So there are three ways to solve this problem. Either we draw the shear and moment diagram or summing up moment at the center of the beam, or by using the formulas of the beam. So first of all, we need to determine the reaction at the support. So if we sum moment at B positive clockwise, we have RA times 15, the moment arm, minus 1200 pounds times 10 feet, which is this one here, 1200. Then we have a 2700 pounds times 7.5, half of the span, and we have the 1200 pounds times 5. Then we have the triangular load. So triangular load, that is 1/2 times 15 feet times 140 pounds per foot. So this is the area of the load times the moment arm, which is L/3, 15 times 1/3. So to determine the reaction at point A, we have only one unknown, RA. So RA is 29 pounds. So then if we sum moment, sum forces along y-axis, that is 2900 pounds minus the 1200s. We have two concentrated loads, so times 2, minus 2700 pounds, this one here, minus the triangular load, the area, 1/2 times 15 times 140, minus RB. So RB here is 3250 pounds. So for me guys, the easiest way to solve the moment here, because we are required to determine the moment at the center of the span. So we can maybe take moment at the center of the beam. But if we are required to determine the maximum moment on the beam, we need to draw the shear and moment diagram, because of this varying load, the maximum moment does not fall on the center of the beam, a little bit shifted on the right. So here, to determine the moment at midspan, if you can see here, if we cut the beam at the center of the span, so what we have is, we have the moment here, we have the shear, we have the reaction, and we have the varying load. But the varying load here is, if we take the ratio and proportion, 140 times 7.5 over 15. So we have 70 pounds per foot here at the center of the beam. So if we take a moment here at the center, positive clockwise, we have 2900 pounds times 7.5, that is the reaction, minus the 1200 pounds, this one, times 2.5, plus minus 1/2 times 7.5 times 70 times 7.5 over 3, because the centroid of triangle is L over 3. So 7.5 divided by 3. So minus m, our moment here. So the moment at midspan, that would be 18.1 kips per foot. So that is the moment at midspan using this equation, static equations. So we will compare this, guys. If you want to use the formula, you can use this also, because if we segregate, if we extract this loading triangular, we have the formula for that. And if we extract also this concentrated load applied at third points of the beam, we have also the formula for the concentrated load of the span. So let's proceed to this formula method. This formula, we can check it in the EIEC table 3-23. If you can check it here, actually it's here. I will show you where to get this one. That is table 3-23. So we have these cases here, actually. This one. So if we use that, if we take moment at midspan, you will just substitute that L over 2. So let's go back to our calculation. So moment due to the varying loads, we have this formula, WL over 8. But W here is the total load of the beam, total load of the triangular, this one here. So 1/2 times 15 times 140 is 1050. So the next one, so that is the total moment at the midspan. That is not the maximum moment, that is the moment at the midspan. The maximum somewhere here, a little bit shifted at the center of the beam. So the next one is the moment at the third points. Like for example, this one, we extract it from here. So the moment for that, the formula is PL over 3. So 1200 times 15 over 3 is equal to 6,000 pounds-foot. This one here. So the next one is the moment due to the point load. This is a very common equation. Formula of moment, PL over 4. So 2700 times 15 over 4. So this is the ways of determining moment at the center using the formula. But for me, sometimes it's very difficult to memorize or this formula, because we have a different load condition. Sometimes the formula is different. So if we sum this up, all these three moments, we will get the value of 1968.75 plus 6,000 here, plus 10,125 pounds-feet. So if we sum that one, if you sum up, we will get the same result, or equivalent to 18.1. So I'll just show you guys how we can differentiate using that equation earlier and using the formula. So that's all for this video, guys. And if you learned something or you found this video helpful, please don't forget to like or subscribe so that you will be updated for the next upload. Thank you so much for watching, and see you next time. Bye bye.